Hello everyone. In this video, we're going to be solving a quadratic Diophantine equation. If you like this video, please like, comment, and subscribe, and don't forget to hit the bell button for notifications. If you don't like this video, please let me know why in the comment section down below. I appreciate all kinds of feedback, and let's get started. So we're looking for integer solutions to this equation. We have two variables, and it's quadratic. So this could be considered a quadratic Diophantine equations. Quadratic Diophantine equations are pretty interesting. They're not too hard to solve, of course, in some cases, right? In some cases, there are no solutions. There are really good resources and books, which I will share the links of in the description down below. All right, so let's get started with the solution. So since this is a quadratic equation, I would like to get everything on the same side. Let me do that first. Okay. So my plan is basically to solve this. But to make it easier for me to solve, I'm going to put everything on the same side. And I'll get the following. Now, this is a quadratic equation, but depends on how you look at it, right? From the x's perspective, it is quadratic. From the y's perspective, it's also quadratic, but there's no y term. So that's not very interesting. I mean, at the beginning, you could have taken the square root of both sides, but it wouldn't really give you anything either. So it's better to look at it from an x perspective. So that's what we're going to do. So our plan is to treat this as a quadratic in x and treat the y as a constant. Okay, cool. So for that purpose, I'm going to write the quadratic formula from an x perspective. X is going to equal, and by the way, y is considered constant, therefore negative 9y squared is also constant, 9 minus 9y squared is also constant. So that's our constant term. Negative b plus minus the square root of b squared. In this case, b would be the coefficient of x, which is 3. B squared is going to be 9. Minus 4ac, a is 1, as you know, c is the constant, so it's just going to go inside the parentheses. And then we're just going to radicalize it. Divided by 2a, which is 2. Awesome. So let's go ahead and simplify this a little bit, and let's see what we get from here. Okay. So now, x is equal to negative 3, right? Plus minus, okay. Now I should be getting from here 9 minus 36. 9 minus 36 plus 36 y squared, correct? Negative 4 times negative 9 is positive 36 y squared. That's going to be under the radical, all of that. Now, we can definitely simplify this because 9 minus 36 is negative 27. So I can just go ahead and write it as negative 3 plus minus the square root of, okay, I'd like to write the y term first. I mean, no big deal, but it just looks better. 36y squared minus 27. All right, here we go. Now, what can I do here? Well, I need to take out a perfect square if possible. And these two numbers actually have 9 in common, and that's a perfect square, which is perfect, right? So I can pull out a 9, and that's going to come out as a 3. So inside, after division by 9, we should be getting 4y squared minus 3. All right? Awesome. This is the critical part. Now, I mean, so far, nothing has been really complicated, right? We just used the quadratic formula, but one of the tricks we used was putting everything on the same side and then treating it as a quadratic in x. Okay, that was the only trick so far. Now, the next step involves, looking at this equation and how can I arrive at a solution from here, right? Because this doesn't really give you anything. I mean, you can plug in millions of values for y, you're going to get some x values, but how do you guarantee that those are going to be integer values, correct? That's the critical part. So for that purpose, we're going to use something interesting. First of all, think about this. You want x to be an integer, right? And you want y to be an integer. In order for x to be an integer, first of all, the radical expression, should not bring any irrational numbers, right? If it does, then you get an irrational, which is obviously not an integer, okay? Well, what is that supposed to mean? Well, it could bring some rationals though, right? Well, here's the thing. You may get a rational number. That's not an integer either, but that's the next step to check. First of all, you have to make sure that nothing inside the radical is a non-perfect square. Okay, I kind of complicated the expression. I think I should probably say, okay, we want to make sure that 4y squared minus 3 is a perfect square. There you go. Okay, it's a lot easier. So why does that need to be a perfect square? Well, because if 4y squared minus 3 is a perfect square, then its square root is going to be rational. Therefore, it's more likely that x is going to be an integer. Otherwise, it's not going to be an integer for sure. Cool. Now, can 4y squared minus 3 be 0? Well, if you think about it, if it's 0, then x will be a rational number, but it's going to be a fraction, and y is not going to be an integer either. We want integers, okay? X and y have to be integers. So what are we supposed to do? Okay, to keep a long story short, and I think I kind of kept it too long, the expression inside the radical needs to be a perfect square. Let's call that k squared. Okay, doesn't matter. I mean, you can use p for perfect, but that kind of refers to prime numbers, so you don't want to do that. So I use k. Okay, so if that's the case, now notice what happens if 4y squared minus 3 is equal to k squared, then you would get something like x equals negative 3 plus minus the square root of 3 times the square root of k squared, which is k, so you'll get something like this. Well, this can be an integer, at least it has a chance, right? Cool. So, as it is, this equation doesn't really tell us much because what am I going to do with 4y squared minus 3? But if you do a little manipulation here, and that manipulation is what? The algebraic manipulation. Okay, cool. Don't you love difference of two squares? I mean, it's awesome, isn't it? Okay, that's what we're going to do. How do you do that? Well, switch the 3 and the k squared, and you're going to get something that's amazing, right? Okay, this is amazing, isn't it? Well, if you don't forget to put the square there, obviously. Now, this is amazing. Why? Because this is difference of two squares. Beautiful. Okay, and we can factor that. And we're looking for integer solutions. So what is that supposed to mean? It means we can factor this and look for integer solutions. Okay, so this kind of brings up another Diophantine equation, but this one is actually fairly easy to solve. So we were able to simplify the problem. Let's go ahead and factor this. So this can be factored as 2y plus k multiplied by 2y minus k is equal to 3. Beautiful. Now, why is this beautiful? Because, first of all, notice that y is an integer and k needs to be an integer as well, because if it's not, then we're going to run into some problems, y not being an integer. So k is an integer, y is an integer, and we're multiplying two integers because 2y plus k and 2y minus k are also integers. Their product needs to be an integer. 3 is an integer, so we're looking for integer factors of 3. In other words, factors of 3. What numbers can go into 3? At this point, we can just kind of look at the options, right? I mean, this can be a 3, and this can be a 1. Let's change colors here. I think this would be a good point to change colors. All right, here we go. This can be a 3, and this can be a 1. And then we're going to look at what it means. Or this can be a 1 and this can be a 3. We're going to look at what it means. Then this can be a negative 3 and this can be a negative 1. We're going to look at what it means. And then this can be a negative 1 or negative 3. And we're going to look at what it means. And this is it, because 3 is prime. Therefore, there's no other way to factor it. And we included the negatives because it says integer. It doesn't say natural numbers or positive integers or something like that. Okay, cool. Now let's take a look at each case. First of all, notice the following. If 2y plus k is equal to 3 and 2y minus k is equal to 1, you add these two equations, you get 4y is equal to 4, and from here you get y equals 1. Beautiful. So this, in other words, this means that if you look at these two values and add them and divide by 4, you basically get the y value. So from here, basically, you're getting y equals 1. From here, you're also getting y equals 1. So it doesn't really matter which way you approach it because they're just going to switch around. From here, you're going to be getting y equals negative 1. Beautiful. And from here, you're going to be getting y equals negative 1. So there aren't 4 values. You only get 2 values for y. Beautiful. Okay, what is that supposed to mean? It means that when looking for x values, you only need to use the 2 y values, which is 1 and negative 1. Okay? How do you find x though? You're going to plug it in here. You're going to use that. It's up to you. You can use the original problem. You can use whatever you want. It doesn't really matter. I'm going to use the original one. Okay, let's go ahead and do that. And the original equation was, what was the original? Okay, it was x squared plus 3x plus 9 is equal to 9y squared. And notice that either you can use y1 or negative 1 for y. It's not going to matter. So actually, there's only one possible value that you can use, which is going to give you a unique x value. Well, I guess I kind of made it confusing, but anyway, this is what I was trying to say. If y equals -1, then you get x squared plus 3x plus 9 equals 9. From here, you get x squared plus 3x is equal to 0, which means x can be 0 or -3, okay? X can be 0 or -3. So this gives you the ordered pairs, basically 0, -1 and -3, -1, okay? Awesome. What happens if y is equal to 1? You get the same thing. Okay, great. Because when you square it, it doesn't really matter. You get x equals 0 and x equals -3. And those give you the ordered pairs 0, 1 and 0, not 0, 0, -1 and 0, 1 and -3, 1. So we have basically 4 solutions and they are all ordered pairs. These are going to be all the solutions. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed the video. I'll see you tomorrow at the same time with another video. Until then, take care. Bye-bye.